Fishtank, Unit 6, Lesson 4, Anchor Problem 1. As I'm looking at these three different diagrams that all show the same thing, I can see that they have something in common. In this first diagram, the tape diagram, I know that the distance of x down on the total would be here. So if I subtract 2 from 6, I will get what x is. In other words, I'm subtracting 2 from this top tape, but then I also need to subtract 2 from the bottom total. The process is very similar in the scale diagram. In order to get x on its own on this side, I have to take away 2 from the left side. But if I remove 2 from the left side without doing anything to the right side, then all of a sudden the right side is going to be too heavy. So I also need to subtract 2 from the right side. And finally, in our mobile diagram, we have something very similar to the scale. I'm trying to isolate or get x on just one side. In order to do that, I want to get rid of these 2 over here. So I want to subtract 2. But if I do that, now the left side will be lighter than the right side. So to make them balance, I have to subtract 2 from both sides. In each of these circumstances, the way you subtract 2 from both sides makes it really easy to see that our final solution to this equation is x equals 4. This is why solving equations is sometimes called balancing equations, because you're trying to make sure that the two sides or the two parts stay in balance so that you can really tell what the x is equal to.